Alright, starting lesson 2.1, reasoning using properties from algebra. Now this is going to be the introduction to learning how to do proofs. Now, students tend to have a difficult time with proofs when they don't have a solid foundation established. And this right here is going to establish the foundation you need to be successful with proofs. So if you understand how to do all these problems in this lesson, then doing proofs down the road will be much easier. Alright, so we have some algebraic properties of equality to go through. So we have the addition property. Here we have if A equals B, then A plus C is equal to B plus C. Essentially, whatever you add to one side, you have to add to the other, correct? I mean, you've been doing this throughout algebra. All right, then you have the subtraction property. Whatever you subtract from one side, you got to subtract from the other. Multiplication, whatever you multiply on one side, you got to multiply on the other. Division property, whatever you divide on one side, you got to divide on the other. Okay, substitution property, and you've used that plenty throughout algebra. Distributive property, all right, you used that plenty throughout algebra. The reflexive property, for any real number, A equals A. Well, you're thinking like, well, yeah, duh, A equals A, 5 equals 5, naturally. But when is this going to come up? You'll see in the future. Then we have the transitive property. And I put train here because it's sort of like having all the pieces to a train connected and then removing the middle part and connecting the two ends. Okay, so if A equals B and B equals C, then you know that A equals C. All right, so now example 1, state the property of equality that applies to this statement. If y plus 5 equals 7, then y equals 2. Well, how would you get this? Well, you would subtract 5 from both sides, right? All right, what property would you be using? You'd be using the subtraction property. Okay, for B, if 2ab equals 25, then ab equals 12.5. Well, how would you get that? You would divide both sides by 2. And that's simply the division property. You're just stating what property you're using to get to the next piece. So I start with this. How did I get here? Well, I multiplied by 3 on both sides. So this would be the multiplication property. All right, and then here I'm distributing. All right, for part E, we have measurement of angle A equals measurement of angle A. Well, anything is equal to itself. All right, and part F, we have A equals 1 and B equals 5 plus A, then B equals 5 plus 1. So you're just essentially substituting this in. That's the substitution property. If measurement of angle A equals measurement of angle B, and measurement of angle B equals measurement of angle C, then measurement of angle A equals measurement of angle C. All right, and that's going to be the transitive property. All right, so these should all be very easy to work with, and these should be like the new properties you have to learn, which aren't that difficult at all to learn. All right, so let's go into some proofs now of algebra. Find x, giving a reason for each step. Okay, now take a close look at your yellow summary sheet. You're going to be using lots of the properties on there now to help you with these proofs. So, statement 1. Where did this information come from? Well, it simply came from the diagram. All right, so you would say the reason for making that statement is it was given to you. Now for part 2, AB plus BC equals AC. Now that's known as the segment addition postulate. All right, you're just adding two parts of a segment up to get the whole thing. Then it says this here. We have this equation. Now where did that come from? Okay, well, we know AB is equal to 3 times 8x plus 12. We know BC is equal to 16. And we know AC is equal to 100. So all we did there was use the substitution property. All right, and now we have 24x plus 36 plus 16 equals 100. Now where did that come from? Well, what did we do before? We must have applied the what? The distribution property. All right, and how did we get statement 5? Well, what took place? We did simplification. Okay, now a lot of students here will say addition property. Why is it not the addition property? Are you adding something to both sides of the equation? No, you're just simplifying. You're adding up like terms. All right, for part 6, well, how did we get this statement? Well, we must have subtracted 52 from both sides. Since you did it to both sides, that's the subtraction property. All right, and then how did we end up with x equals 2 at the end? We divided by 24. Okay, so that's using the what? The division property. All right, next example. Given ray BD bisects angle ABC, bisects the angle, find x giving a reason for each step. All right, well, bisects, so what do you know about these two angles? They're the same, right? Okay. So, statement 1, BD bisects angle ABC. That's a given. Statement 2, measurement angle BD equals 8x minus 16. Measurement of angle DBC equals 4x plus 20. That information was just given to you. All right, it's in the diagram. Then they say measurement of angle ABD is equal to measurement of angle DBC. Well, how do we know that? We know that because the angle is being bisected. So if you look at your yellow sheet, you'll see that the reason we use is the definition of angle bisector. All right, now for part 4, 8x minus 16 equals 4x plus 20. Where did those come from? Well, we're just substituting in the equivalent expressions here for those angle measurements. All right, then what happens next? Well, we added 16 on both sides. So we did it on both sides. So that's the addition property. And then for 6, we subtracted 4x on both sides. So that would be the subtraction property. And the last step was dividing by 4. So the reason for this statement is we use the division property. Last example. All right, given AB is congruent to BC, AB is congruent to BC, and BC is congruent to CD. Okay, BC is congruent to CD. Find x giving a reason for each step. All right, so the first statement, where did that come from? Well, that's just given. Where did the next statement come from? AB is congruent to CD. AB is congruent to CD. Well, that's applying the transitive property. All right, here it comes now. And then here we have AB is equal to CD. Where does that come from? Well, before we had AB is congruent to CD, so we also know that AB must be equal to CD. And that's simply the definition of congruence. All right, you could go from congruence to equality, equality to congruence. All right, and for statement 4, where did this information come from? Well, that's just given. It's already in the diagram. All right, and the next statements, where did this come from? Well, they substituted this information in. The third statement, so this is simply the substitution property. Then what happens next? 1 was subtracted on both sides, so that's the application of the subtraction property. And then what happened next? We subtracted 4x on both sides. So that's once again the subtraction property. And then we're dividing by -2. So that's the division property. That's what gives us our final statement. All right, so this is the very beginning, the foundation for developing the understanding of how to do proofs. Proofs is going to be a big piece in the upcoming lessons. So if you have any questions, make sure to ask. And make sure to use your yellow sheet and get very familiar with all the properties on it, because you're going to be using it all over the place in this chapter. All right, begin the assignment.